the keyword override. Okay. So let me summarize whatever we learned so far. Okay. We learned some of the rules of the inheritance. Okay. So we came up with 6 rules. Okay. We learned some of the keywords that we use in C# to eliminate ambiguity as related to inheritance. Okay. So let's summarize those. Okay, so for inheritance, the idea was start creating some classes. As soon as you've written a few classes, you yourself will discover that you are repeating things. Okay, so as we saw through the color coding, if this part, this part, this part, this part, this part, this part is the same. Okay. At that point in time, you will create the base class. So let me emphasize, good programmers do not start with the base class first. Okay, good programmers will create the real physical entity classes first, and then they will discover we are repeating things, and then they'll take the common things out. And the reason is because we inherit everything. Okay. If we created the base class first, we may end up putting something over here which is really not needed in a derived class, which is violation of one of the important rules in good software development, right? So anyway, as we create the base class and move the common things over here, so these go away, right? Okay, now we can of course add more fields. So you can add an extra field over here. You can add 2 extra fields over here. It doesn't matter. You can add extra method over here, add extra method over here, right? But what if we wanted to override it and provide our own code, not the code that was written in the base class? Okay, then how will we mark this method over here, which already has real code in it? Virtual. Okay, so we'll mark it as virtual, and then we will override it, right? Now, what if we, from here, we further create another class, and we further wanted to override it? So from an override, you can keep going and keep overriding as many times you feel like it, right? Now, suppose there was another method over here, okay, which has identical signature. Okay, but code is different. Then how will you declare it? So you will not put any code over here, you will put abstract over here. Correct? Mm-hmm. And then as you inherit from here, because you're writing some real code over here, so you will use the keyword override over here and override over here. Okay, so let me go to my computer, and I'll show you very quickly some of the code that we will need to create the university application, and how gradually we'll refactor it. Okay, or let me briefly describe it first.
I have a question.
Uh-huh.
So you talked about how you can, the 3 ways to signal that you can override a method through abstract, virtual, or override.
Correct.
If you're using override to override another method, is it possible to start the chain of override? For example, in the base class, if you use override instead of virtual, would that functionality?
No, in the very, very top level class, the chain is started with the virtual keyword. And why virtual? As I explained, I'll go over it a little more detailed, maybe in the next lecture, so that you completely understand. Okay, so now let's pretend our goal is to create a university application. Okay, and let's pretend the real entities that we will create, meaning the classes and the objects that we will need to create in our application. And again, let's pretend we have a part-time student. We have an undergraduate student. We have a grad student. We have a PhD student. Okay, so this is the student side, right? In a university, we also have employees. Okay, we have professors. So pretend there's a faculty. There's an employee. Okay. There might be. So anyway, there might be, dorms and so on, and labs and so on, and lab managers and so on, right? But to keep the example simple, right? Let's start over here, okay? So as I mentioned, if these are the real entities that you wanted to create in your application, you'll start creating classes for these, right? So you'll create a class for part-time student, undergraduate student, grad student. Okay, for right now, let me assume this uses 0.4 times the formula for computing grade, 0.4 times, 0.4 times, let's say 0.5 times for a PhD student. Okay, so let's start from the student side, right? So you may start creating a class called undergraduate student. Okay, you'll put the 5 fields over here: first name, last name, ID, test 1 and test 2, right? Okay, and you will also write the formula for compute grade, and with the 0.4 times whatever code, right? Okay, then you'll start with the grad student. Okay, and let's pretend that these 5 fields are the same, but the extra field is the thesis. And you will write the code for the compute grade, and 0.4 times, so same formula. So as soon as you have created these 2 classes, what will you do? You will create base class. Okay, what will you call the base class? Okay, you can, again, in the beginning, even if you didn't pick a perfect name, it's okay. Gradually, you will recognize we need to change things. You will, what's called refactor your code. Okay, so let's go create a base class called student for right now. Okay, what are the common things over here? The first 5 fields, right? So let me mark those. Those were the common. So I'll put them in the same color. But thesis is not common. So 5 fields. Okay, is the compute grade the same?
Yes.
So you will also put the compute grade over here. Okay, with 0.4 times whatever code, right? Now, tomorrow somebody may want to override it and provide a different code. So to allow somebody in the future to be able to inherit from student and change the code for compute grade, what will you mark it as? Virtual. So let's mark this as virtual. Okay. So now over here you will go and inherit from student, inherit from student. So what happens to all the code over here? Disappears. See how easy it is to create the class now? Okay. What happens to the code over here? Only thing remaining is pieces, right? Now let me mention also, we had gone over this before, we always write two constructors, okay? One with as many parameters as the number of fields, and one with no parameters. Because as soon as we write a constructor with parameters, C# takes away the default constructor, right? Okay, so I forgot to give you one rule special to C# related to inheritance, and one extra rule is constructors are not inherited in C#. Unlike C++, where the constructors are also inherited. Okay. So if we write a constructor in the base class, it will not be available in the derived class. Okay. So over here, how many constructors you will write? Right? Constructor without any parameter. And constructor with five parameters. Everybody agrees? Remember, the constructor has the same name as the class name, no return type. So for example, how will the first constructor look like? Public student, begin curly, end curly, no code, right? How will the second constructor look like? Public, same name as the class name. Now 5 parameters. For example, string LNM. Sorry, let's start with the first name. FNM, LNM, and int ID, int test1, int test2, right? And then what kind of code we'll write? We will say first name equal to FNM, last name equal to LNM, this dot ID equal to ID. So again, to